Assalamualaikum warahmatullahi ta'ala wabarakatuh. Welcome to another video on MCTE 2311 Signals and Systems Analysis. So this time I will show you the solution to question number 2 on impulse response, where you are given this differential equation and you are asked to determine the impulse response of the system. So the first step to do is to rewrite the differential equation in terms of the operator D, where this capital D is equals to d over dt. So in this case we have d plus 3 y of t equals to d plus 2 x of t. Okay, so the next step is to determine BO and PD. So in this case we have M equals to N. This M is actually the power of D for the input, and the N is the power of D for the output. Okay, so here we have dm, okay, equals to 1. This D equals to the power of 1. This D is also to the power of 1. So M equals to N, okay, which is 1 and 1. So in this case BO is not equals to 0, okay, where BO is the multiplier of D to the power of M. So BO equals to 1. Now PD is simply this polynomial. So PD is equals to D plus 2. The next step is to determine Yn of t by finding first lambda, which is the roots to the characteristic equation, and also C. Now the characteristic equation is Q lambda equals to 0, which we obtain by simply substituting the D in QD with lambda. So we have this QD, okay, which is D plus 3. So let's write lambda plus 3 equals to 0. This is our characteristic equation. So we will have lambda equals to minus 3. This time we only have 2 lambda. Okay, so in the previous examples where I discussed zero input response, and even in question number 1 for the impulse response, we have multiple lambda. That is because we have a second order system. But this one we have a first order system because here is a first order derivative. So our lambda is only 1, okay, which is to be expected. Now the general solution for Yn of t, okay, since we only have 1 lambda, will be Ce lambda t. Okay. Now we need to find C. Yeah, we have the lambda. So if we substitute the lambda, it will be Ce minus 3t. So next step is to find this C. We can do that by applying the initial condition. So we know that n equals to 1. So Yn of 0 is equals to 1. Okay. So we substitute this t over here with 0. Yn of 0, which is equals to 1, equals to Ce to the power of 0. So 1 equals to C. So our Yn of t is equals to this is 1, so is E minus 3t, okay, which if we differentiate, okay, just differentiate just in case we might need it later, it will be minus 3E minus 3t. Okay, so the next step is to find h of t, which is given by this equation over here. So let's substitute everything because we have all of them. H of t equals to BO is equals to 1 sigma t plus PD is t plus 2. We obtain this in step number 2. Yn of t ut. Okay, so this one equivalent to sigma t plus, if I multiply this, I will get the yn of t plus 2 yn of t u of t. Now this part here, okay, simply means d yn t over dt, okay, because capital D is equals to d over dt, right? So can write again as sigma t plus yn dot, okay, the first derivative of yn plus 2 yn t ut. So we can substitute now, okay, the yn dot t and the yn t that we obtain here, okay, into this equation. So we will have here minus 3e minus 3t plus 2e minus 3t u of t plus this one is minus e minus 3t u of t. So the h of t is sigma t minus e minus 3t ut. Okay, so this is the impulse response of the given system. I will see you in the next video for solution to question number 3. Thank you.